And it's very interesting also, we hear a lot about, GMOs, and there's, a lot of people are hesitant for, to eat GMOs, even though it's perfectly safe. A lot of the techniques that we use GMOs to get, for example, enhanced disease resistance or enhanced drought tolerance, for example. A lot of those we can also get from just through breeding programs and selective breeding. So it's, trying to calm some nerves that, there's a perception that GMO means, equals bad, which isn't the case.
Yeah, actually, I wanted to ask you about GMOs too. So I guess like I kind of agree with you. Like the stuff that I've read about GMOs, it seems like most of the the applications of them, like the way that they're used is like they're relatively safe. Because there is some noise about like, well, like should we be like modifying the food we eat? There'd be like harmful effects. Could you kind of go into like your thoughts on GMOs and like their safety, what potential positive impacts they might have on certain crops?
Yeah, absolutely. So it's really amazing how versatile they can be. For example, I mentioned enhanced disease resistance, but also more nutritious crops or better tasting tomatoes, for example. So there's a lot of different applications. And they have an amazing safety profile. So there's only been maybe like one instance where there could have been an issue where there was like an allergen issue with like a Brazil nut, I believe, that, even before it went to market, they caught this potential allergy issue and then they never even made it to market. So all of the, GMOs that are out there in the US market are very highly regulated, go through a lot of, numerous safety tests and everything before they even get to your store shelves and everything. And, there's, obviously if you have like an evil person who wanted to like make a negative GMO, they could, make like a GMO that's like concentrated with arsenic or something, that could be done, but that's never happened. And it's, they're so highly regulated that that's not going to happen. So.
Okay, good thing I'm not going to go to the like supermarket and be like, oh no, there's arsenic hidden in my food.
Yeah, that definitely won't happen.
It won't happen. Okay, good. But like the main uses then of GMOs are to they're mostly like to increase the life of crops and produce more of them, right? Is that kind of?
That's one application that you can use it for, making, crops that have higher yield is what we call it. But that's, just kind of one of the, many things that they could be used for. Another example could be like longer, shelf life, fruits and vegetables that are like less prone to bruising or ripening too quickly. Those types of things can also be manipulated also.
Is there like a plant vaccine or like GMO or pathogen that you think is going to have like it's going to be like the next big thing in like plant biology? Like, is there one thing where you say like, oh, that's going to cause like another like plant pandemic, or that's going to allow plants to live, or like a certain type of plant to live for longer?
Oh, that's a great question, Emerson. And there's a few examples I can think of. I don't know if you've heard of the golden rice. So it's this GMO rice variety that's way more nutritious. And then when you think of rice as being the staple food for such a large percentage of the world population, I think, if that could be more accepted, because it's really the GMO thing that's kind of holding that up. There's also flood tolerant rice. There's, I'm thinking of staple crops, it's having the biggest impact. Wheat varieties that are resistant against wheat diseases like wheat blast, that sort of thing. A historical example was the Irish potato famine caused by an oomycete pathogen, Phytophthora infestans. And now there are ways to, there are GMO potatoes that are resistant against that disease. And then kind of going down, I mentioned the citrus treatments that are coming out. There was a banana variety. So if you go to the store and get a banana, like it tastes like kind of like what we think of a banana would taste like. But if you try like a banana flavored candy, it tastes nothing like the banana flavored candy would. And that's because this banana flavoring was actually based on an older variety of banana that almost got wiped out, called the Gros Michel banana. And they're still around, but they're very hard to come by. But apparently they taste way better than the Cavendish bananas that we buy at the store now. But even the Cavendish bananas are under threat from fungal pathogens. So there are a lot of research going into the banana diseases also that are there. Those are some off the top of my head.
The banana diseases, like are those like to protect against those pathogens? Are those things that like you have to like are those things that you have to change, like you have to like change like the genome of the seed, or are you able to like vaccinate the banana plant later in its life?
That's a great question. So bananas mainly are clonally propagated. So a lot of them are exact same genetic makeup in the area that they're grown in. So that can be very Achilles heel type. So if you have a pathogen that comes in, they can just like wipe out that whole area of banana plants. A lot of stuff that's done now is doing the genetic modification that you were talking about from the seed stage. But also a lot of it is treatment of plants that are already infected using like fungicides, for example, which can be effective, but then you also have the the dangers of the fungicide application that could potentially be consumed by people. So that's potential like stumbling block, I would say. So I think most people, given like, do I eat a GMO food or do I eat a food that's been doused in fungicide? I think most people would probably choose the GMO route. So
Yeah, actually, so what are like for that fungicide, like what are some dangers of that? Because it sounds like they can be like harmful to humans, like if you eat when that pesticide has been like applied.
yep. So it depends on the exact type of whatever the chemical that's being applied. So it can vary from, there's a lot of different pesticides that are being used and fungicides that are being used. So I can't speak on them specifically about like what are the potential hazards of ingesting them, but I would it's something, if you are buying potatoes, maybe looking to see for the manufacturer kind of, or the producer, what chemical agents are being applied to that specific food item.
I see. But like I mean, like it also sounds like using GMOs for plants is a lot safer than using pesticides, right? Like if you had to
Definitely.
like if you had to pick, like if there was a very like if there was a plant that was like very susceptible to being damaged, you'd much rather use a GMO for that.
Definitely. Yeah, for sure.
And that's like mostly because like the GMOs have been proven or have been mostly shown to have like very little to no harmful effect in humans, but the pesticides have been. Is that like kind of like the correct way to think about it?
Exactly. So even with these pesticides, fungicides, you're going to have these warnings associated with them. Whereas GMOs, as I mentioned, are they've gone through a very strict regulatory process. And historically, if you look back, they've had almost just 100% successful, safety profile. And I did mention that one example that before it made it to market, got taken out. So
And then like, could you actually go into like really quickly, like technically what a GMO is, like how the plant is actually changed?
yep, so that's a great question, Emerson. So GMO is short for genetically modified organism. So humans have a genome, plants have a genome. So the method that typically we use to make GMO plants is we have this bacteria called agrobacterium, which is a bacterium that can insert DNA into plant that it's associated with. And so we do this technique called agrobacterium mediated transformation is what it's called. And so when you transform the plant, you basically put your gene of interest into the plant using this bacteria that has this ability to insert the DNA into the plant genome. And it's typically a kind of a random insertion, so it can kind of go anywhere in the genome. But with modern techniques, we have ways to kind of target where we want these genes to go into. So